Hey Pranav, can you go hold that target for me?
Oh yeah, sure.
Thank you, Pranav. Oh no, Pranav!
Pranav gets shot.
Introduction. The purpose of our experiment was to find whether the spring constant of a string of a bow was linear or nonlinear, and if it was linear, what the spring constant actually is. So going into the experiment, we believed that the spring curve was nonlinear, and we wanted to test the speed of the bow by measuring how long it takes the arrow to go 1 meter. We also wanted to see how far we pulled back the bow to find the distance, and how long it takes to return back to the equilibrium point. And here are some of the equations we thought we were going to use to find all these values. Materials and methods. So we first set up a hay bale to shoot the arrows at so we'd be safe. Then we set up a tripod with a meter stick so we could see how long it would take the arrow to go 1 meter, and using that we could find the velocity of the arrow. Then we pulled back the bow at different lengths and recorded this distance that we pulled it back, and recorded 3 trials per distance. And lastly, with all those values, we could find the velocity and the distance from the equilibrium point, and therefore find the spring constant. At 10, take 1. So here's a look at the data for our experiment. We recorded the average force versus the distance for a taut bowstring, and as you can see, as the distance increased, the average force of the bow progressively also increased, and the slope we found was 43.72 Newton meters.
Data and results. We discovered that the spring constant of the taut bowstring was linear, as corroborated by a similar Harvard study conducted a few years ago. As we increased the distance that the string was pulled, it seems as though the distance and the speed with which the arrow traveled was proportional. This basic observation also corroborates our technical data as presented earlier in the graphs and tables. Discussion/CR. The purpose of this experiment was to determine the spring constant of a bow and arrow and whether its force curve is linear or nonlinear. For the taut string of the bow tested in this experiment, it can be concluded that the force curve is in fact linear and the spring constant is 43.72 Newton meters. Using vernier graphical analysis, a best fit line for the 18 data points we took turned out to be linear. For this linear best fit line, the correlation constant R was 0.8213, indicating a strong positive linear relationship. The correlation constant was between 0.7 and 1, indicating strong and linear relationships. In terms of finding the value of the constant itself, it was apparent that it had to be the slope of our relationship between average force in newtons and distance in meters. Conclusion. So, the force exerted by a bow and arrow is linear as derived from the best fit line of our data of average force versus deflection, which is the distance the taut string is pulled. Our data is corroborated by a Harvard study conducted in a similar fashion as well. So, the taut string on the bow and arrow follows Hooke's law. As distance increases, so does the force in a linear fashion. Some sources of error that we determined could arise was our method of calculating velocity, which only calculated horizontal velocity and did not include the vertical component. Another source of error is that we didn't take air resistance and wind into our calculations. Additionally, our measurements lacked precision and weren't 100% repeated.